Hey everyone, the purpose of this video is to recap on part A and part B of question 5, leave insert question, and also to show you how to attack part C of a question. So part A of the 2019 U-value question, I've just filled in the information that they've given us. So I'm going to just work it out and go from there. And once I've got my total resistance, I'm going to divide that into 1 to get my U value. Okay, so it's external render thickness and the small r. These are my two formulas. So I have a small r and a t. So I multiply one by the other to get the answer. So what I have is 0.016 multiplied by 2.170, and my answer is 0.347. Okay, so this time it's conductivity, which is the K, and thickness. So it's thickness divided by conductivity to get the big R in this case. So my thickness is 0.1. and I divide it by 1.44, 0 equals, and I get a total resistance of 0.069. Okay, so the cavity, they give me a resistance, now I have insulation and block work. Both of those I've given conductivity, so I divide the conductivity into the thickness and that's what I get. So I get 0.05 divided by 0.037 and I get 1.351. Now for the block work, it's going to be the same as above, believe it or not. So it's going to be 0.069, and plaster is resistivity. So I just multiplied the thickness by the resistivity, and it's 0.012 multiplied by 6.250, and I get 0.07. Now when I add all those up, I will get total resistance of 1.939. Okay, so now I just divide 1.939, divide that, and I get my U value, and I should get 0.516. Okay, so that's my total U value. So now I go on to trap. So I'm looking for the total heat loss. Okay, so trap is how we solve it: time, rate, area, and price. And only thing we have to work out here is the time and the rate. These two are given in the question. So the price they give us here is 0.94, which is 94 cents. The area is 135 meters squared. The rate is the U value, right? So U value multiplied by temperature difference. Okay, so the U value is 0.516, and the temperature difference for it is 19 minus 5 is 14. So multiply those out to get my rate. Now the time, okay, so this is where I have to read this. So it's for 9 hours a day for 9 hours daily for 37 weeks of the year. So there's 60 seconds in a minute, there's 60 minutes in the hour, there's 9 hours a day, there's 7 days a week, and that's for 36 weeks. So I'll work that out then. So let's see what I get. So 60 multiplied by 60 multiplied by 9 multiplied by 7 multiplied multiplied by 36, and I get 8,164,800 seconds. Okay, so now what I'm going to do now is I'm just going to work out what this is here also, actually, what I'm here. So 0.516 multiplied by the temperature difference. So the rate here is 7.224. Okay, 7.224. So now I'm going to multiply them all out on top. So 8,164,800 multiplied by 7.224 multiplied by 135 multiplied by 0.94, and that is all divided by the calorific value, which is given in the question again, which is usually in around 37,350, and it's going to be multiplied by 1,000 kilojoules. Okay, so when I multiply that out, top line first, I'll multiply the top and then the bottom line. Okay, so the top line is 8,164,800 multiplied by 7.224 multiplied by 135 multiplied by 0.94, and I get 7,484,881,178.88. And then when I multiply these two out, I just add my zeros to this, so it's 37350, and then it's 1, 2, 3. So then I'm going to divide that into that to get my total heat loss, divided by 37350,000, and my answer is 200. I'm going to say 40 cents. Okay, so that's what it comes out in around that. Now, some people might get a small bit different answer. It doesn't make a difference. It all goes down to how far you go in your decimal points. Okay, so if it's in around the 200 mark, you're going to get full marks. Now, the last part. Okay, so this is what this video is mainly geared at. Okay, so I've pre-drawn this. All right, so in the question they're talking about a traditional wall, which is, as you can see, outside and inside. So you have your 16mm render, you have a 100mm concrete block, your cavity of 50, your insulation of 50, then you have your inside block work of 100, and then your inside plaster, right? In the question, they want us to upgrade from 0.156 of a U value to 0.15, which is huge. And how we attack this question is quite simple. Okay, so what I've done is I've reverted back to total RT, which is resistance total. All right, so back to the very start. So our total resistance here is 1.939. Let's go back over that, 1.939, and then our new one is 6.667. Okay, so there's a huge difference. So what is the difference? So 6.667 minus 1.939. Get my calculator up then, so 6.667 minus 1.939, and the difference is 4. Okay, so that is our difference, right? So what we need to do, right? Now I need to go back to the first part of the question here. Right. So what we need to do is we need to upgrade our total resistance in the question from that to that. And in order to do that, we need to add on that amount. Now that is the resistance. Okay, so we need to improve our resistance, right? So I need to go 4, 7, 0.28, right? So that's the resistance of that, and it has to be the insulation, so poly insulation. Okay, so that's what that needs to improve on. Now, in the question, right, the 2019, they let us know that the thermal conductivity of this insulation, right, is 0.0, sorry, wrong area, 0.031. So that's our conductivity. So in order for us to get that, right, we have to use the formula, right, that gives us the conductivity. So the formula that we have to use is the big R is equal to thickness divided by K. Okay, so therefore we have a resistance which has to be 4.728. Thickness we don't know, and conductivity is 0.31. So all I'm going to do is I'm going to take that and multiply it by that. Okay, so I'm going to get my calculator out again. So I have to go 4.728 multiplied by 0.031. Therefore my thickness, is equal to 0.147, right? So that is 167 millimeters. That's what we need to improve by. That's how we need to grow by. Okay, I hope this helps, guys. Let me know if it doesn't, please.